Okay, so today we'll continue with the questions on the Google Doc. So any questions related to your Lab 2, feel free to interrupt me with a follow-up. That's okay. Okay, let's start with this example over here. So we already talked about yesterday. Let me just remind you very quickly what we said yesterday, which is quite critical in terms of writing your contracts. Yesterday we talked about why in the green one, you should really use implication as opposed to conjunction. And also for the pink one, you should really use conjunction as opposed to implication. So these two logical operators are not equivalent to each other. So using one but not the other, you definitely need justification. So that's what we learned from yesterday, right? So now I do have some more follow-up example from your colleagues. So let me maybe two more, okay, quickly. 1, 2, 3. Two more actually. Okay. So now your fellow student was asking the following. So when they actually follow my instruction, which I really appreciate in the lecture video, they simply pause the video and try to come up with their own solution to the for this particular exercise. So they were asking about the following: would it be enough if they only got a pink one over here? Would it be enough? Right? So that's basically their question here. So if you think about it, so the answer will be no. Okay. So now let me write down the conclusion first, and then I will tell you how you can justify this. That'll be quite important as well. Having this only is not sufficient. Okay, remember, each one of them is basically checking for subset relation. And now you can think about, we talk about these two sets, right? This is the set to say over here, this is all the numbers in the result, right? And this is the set of all the numbers that are positive in the input set. So we talk about S and T, okay? If you talk about a pink one over here, right, which is what your fellow student did, this one here is really checking that T is a subset of S. So now, would that be enough to make sure that S is equivalent to T? Apparently, mathematically, we know that it wouldn't be possible. So it would not be sufficient, right? So first of all, it's not sufficient. That's a short answer to your fellow student's question. But now, to really understand properly, you want to know if we only got this particular postcondition, only this one here, and what can be wrong at the runtime? What can be problematic? So that's the question we want to answer, right? So now I would suggest the following. I'm going to talk about this one specifically, and then I'll give you some optional exercise you can try to really strengthen your understanding. So that will be the deal. Okay, you can definitely check your answer with me either by appointments or during office hour later. Okay, so let's say this. If I want to know whether this will be sufficient or not, just by this alone, let's imagine that we actually don't have this guy here. Let's say we don't. Okay, so for now, I'm just kind of cross this out. Let's say we don't have this. We only got this right-hand side over here. Would that be enough? It would not be enough. So now, conceptually, you can think about, if you think about this is the set T, and this is the set S over here. If we can only prove that T is a subset of S, so that means there might be some element over here that's actually in S, but not in T. Agree? Okay, so that means, how do we translate this particular example to, translate this idea to this particular example? So now let me give you a witness. Okay, so this is a witness. The witness will be, what if the T is smaller than what it should be, basically, right? Let's say the T smaller than what it should be. More precisely, let me give you a concrete example. Let's say we are still trying to call this particular feature over here all positive values, right? So I'm going to write this here. So all positive values. Okay, let me just give you an example here. Just small ones will be enough. Let's say we got -1, and we got 2, and then we got 3, and let's say we got -2. So this is the input array over here. So that's the input. We know pretty well the correct output should be 2 and 3. We know that, right? But what if, let's say we got wrong output. Let's say we have wrong output over here. Okay, yeah, it's a little bit to the boundary of the iPad, but hopefully you can still see it. let's say the round output is, let me put it here. The round output is simply just, let's say just 2. Apparently you can see this is wrong. If the output is simply wrong, what do we expect to see really at the runtime? We do expect to see like a post-condition violation. But now in this case, are we going to get a post-condition violation? It seems like we are not going to, right? Because if you try to check this one here, right? We're saying that across the result, which means, so this is the result, by the way. Let me just annotate it for you. So this is the result. Okay, so now we're going to say across the result, in this case, the first iteration, we're going to look at 2. And then first of all, x will be 2, 2 larger than 0, that's true. And also the input A, which is over here, has 2. In that case, 2 is over here, so that will be true. So overall, the universal quantification, which will only run 1 iteration because our result size would just be 1. So now the post condition would just be true. Okay, let me write it down. So that means no post condition violation. And this is definitely inappropriate. All right. So guys, do you follow so far? Okay. So what I have tried so far is just to, trying to justify to you. You definitely need both of them to actually check that the 2 sets are equal. If I simply say the question goes like this: if I only got a pink one but not a green one, in that case, I'm only checking that set T is only a subset of S, which means in theory, if maybe set T is simply like a proper subset, meaning that T is actually strictly smaller than S. There's some element over here in S, in this case, some element over here, let's say in the input array, let's say 3. But 3 is not really in 2, the result. But as far as the post condition is concerned, it will still be okay. Okay? So that's why it's problematic. Okay? So now what will be the exercise for you if you don't have any questions? For those of you who might want to strengthen your understanding about this, I would suggest you actually, number one, you would try to think about what if, okay, number one, let me see, exercise over here. So what exercise for you to do? Let's say there is, let's say we only, so here we are trying to check to see if T is a subset of S, right? So now what if we only check S is a subset of T? So now we are doing the opposite direction, meaning that we're only going to check S is assigned to T. So now we don't have this anymore, but we actually only have this. That's the opposite direction. And now, would that be acceptable post condition? Would that be enough? Well, in theory, it will not be enough because in this case, you will only check to see that S is a subset of T. There will be some elements that's in T, but that's not in S, in which case you are going to have some unexpected behavior. So that's something you will have to actually take care of. Okay. And then eventually, you may also want to write for these 2 post condition over here that we talk about in the lecture. You may also want to write some post condition tests to test them. So you know already how to do post violation tests. So that'll be some optional exercise for you. All right.
Sorry, Jackie.
Yes, go ahead, please. Question.
Okay, good. So I was the one who asked this question.
Yes, go ahead. Yes.
I didn't want to interrupt because it would, like the way you interpreted my question was still interesting, but it's
okay,
not exactly.
Okay, go ahead. So maybe just tell me exactly what you meant, please.
So I was asking, like, if you kept, you see where in the original question it says across result is X for all X greater than 0. Yeah, that one there.
Yeah, okay.
So I was asking, like, if you keep that, do we still have to check in the pink post condition whether X is greater than 0?
Oh, actually, Ofek, I believe there might be a question over. Okay, you know what? Let me treat it as a different question here. Okay. Ofek's question is actually different from what I just said, so it's not really conflicting. Okay, let me rephrase your question. Ofek's question was like this. Let me actually, you know what? His question is, let's say we still keep this particular post condition here, saying that every element in the result is positive. And then in that case, can we simply get rid of this particular conjunction? Is that what, Ofek, is that what you meant?
Yeah.
Yes. In that case, correct. That'll be okay. Let me write it down precisely for everybody. Okay. I think this example here, actually quite many things that we can talk about. Okay. Let me just be precise about what Ophek is saying. It's like a more like a different perspective. Okay. What Ophek was suggesting is, let's say we still keep this particular post condition over here, and then for the pink one over here, we can simply just get rid of this guy here. So this will be okay. Yes. If you think about it, which I wouldn't write, it's actually corresponding to maybe distributing the conjunction over universal quantification, something like that, that you learn in 1090. So that's something you can try to prove yourself if you're interested. But I can tell you that it is okay. You're simply just checking this. You're moving this into a different loop to check that everything is positive. So that'll be okay.
Okay, thank you.
No problem. Okay. So guys, actually, what Ophek is saying is actually a valid point. So there are many ways for you to specify a complete post condition for a particular problem here. So of course, I'm only suggesting in this case over here, I'm just trying to tell you exactly S is a subset of T and vice versa. That's why I only gave you two. But what Ophek is suggesting is also fine. So now in this case, you can split the pink one over here into 1 and 2. So with there's only one, there's no conjunction here, just A dot has X. So that'd be okay. But you still need the green one over here. So the discussion I just made in the very beginning, they still apply. Okay, it's not a problem here. All right. Okay, I will go to the chat in a moment. I can see something going on. Let me just say one more thing about this particular example. Okay. One more thing about another fellow students here. They said they still want to keep. Oh, okay, that's your question, right? I guess.
Yeah.
Okay, good. So this one is already answered. Okay, this first part here. Okay, that's good. I think we still got a second part. You were asking about, should we not also check that every member of A was unchanged to fully have a complete post condition? Yes, I agree with you. Yes, I think in this case, you know what? This is interesting because the A over here is actually a parameter, right? I never tried this myself. You're suggesting conceptually something like this. You can even say A tilde O. I think using tilde might be a little bit dangerous because you don't necessarily know whether it's object comparison or the other way. So I think what you're writing over here is pretty good. So I think what you're writing is you want to say across. You want to say A dot count. First of all, the count should be the same. Equals old A dot count. Number one, the count should be the same. And we did something similar in the previous Q&A, but I'll just write it down for everybody. You can say across, let's say 1 until A dot count. Let's say index I, assuming that I doesn't clash. And now you can say all. Now you can say A at position I, tilde, so now we'll be okay. So depending on what the element type is for the array. And then over here, we can say alt A dot deep twin over here at position I. So I think that's what Ophek really meant by complete post condition. Conceptually, I agree with you. But the tricky thing is we are talking about parameter over here. So I think it is true according to callback value, like what you learned in 2030, right? Because there might be some wrong implementation, for example. The wrong implementation could potentially say A dot force, for example, right? And then you can actually insert something to the end of the array. So in that case, it will be necessary to check this. However, I would say in this course, we're making some implicit assumption. We can assume that typically for any parameter that's actually of type object reference, we can assume that the object will just be kept untouched. So that's not something you have to worry. So that's why when I actually talk about complete post condition, I said only worry about the attributes. So it will not be necessary just for the context of this course to really also worry about the parameter. But it's good to think about it conceptually. Okay. Hi, Robbie. Questions?
Because then we all know that A equals old A.
You mean over here? Sorry, Robbie, you meant this expression here, or?
Because then we just get into the course like A equals old A.
A equals. So Robbie, are you saying that can we write an equal sign over here?
No, like instead of the cross. Sorry.
Robbie, it's okay. How about I take your question maybe offline? You can maybe I can try to understand you more properly. Okay, so Robbie, maybe drop me a message, and I can handle that more properly. All right. Okay. Okay, guys. So in this case, okay, that's good. So I would say if somehow we don't have this particular parameter over here, let's say A is only an attribute array. In that case, by all means, you should really do this particular postcondition to make sure A, number one, the size doesn't change, and number two, the contents stay the same over here. Okay. However, if this is only for parameter, you can safely assume for this course we don't actually change by using call by value. Okay, that's something you can assume. All right. Okay, so that's about this particular example here. Okay, I would say, yeah, really think about it. Really think about yourself about the distinction between conjunction versus implication. I think it's really quite important to apply that in the programming context. Okay, so let me see. Okay, so far discussion is still about the Zoom sign-in. Okay, okay, this one here. So now, this question here, I saw that just from earlier this morning. So I think that's a new question, but I think it fits better if I talk about it now. Okay, so the question goes like this: if I have a defer routine over here, could I directly redefine this particular routine in another class in Eiffel rather than making effective? So let me tell you what your colleague really means. Remember in the example that's in the lecture, right? So I think we said something like, you got, for example, a deferred class called database. Similar to your database class, in Lab 2, similar. Let's say we have a search routine. I'm not just being a little bit informal here. Of course, if you want to put any routine for your diagram, you should really show the detailed view. Okay, so I'm just being a little bit lazy here. Let's say in a database level, we got search that's being deferred, and search maybe just return a Boolean. Okay, just make it simple. Okay, and then there might be some parameters over here, right? So that's deferred. So your colleague's question goes like this: is it okay to really say, let's say we got inheritance over here. So we got inheritance over here, and then we have, let's say, database, I'll say DB, version number 1. And let's say in this case, it's effective. Okay, your colleague's question goes like this: can we simply annotate the search like a ++? They thought it should be okay, because if you say plus, that means it's effective. If you say ++, it is still effective, so it shouldn't make a difference. Okay, that's a good question actually. So I would say it would be wrong if you say that like that, because when you say ++, it has a very special meaning about redefine. Redefine meaning that there is already an effective version in the parent class, and you're trying to redefine that. So having ++ over here doesn't really make sense, because the search over here is not even defined. How can you redefine it, right? So in order to redefine something, that thing must be defined first of all, right? So now that doesn't make sense. So you must say, so this is wrong. Okay, you should really say search plus over here, right? And then let's say if you got another inheritance relation over here, and then here you say DB version 2, and then it's still effective. Now in this case, it will be okay. Okay, now you might be wondering again, can I just say search plus? The answer is no, that's also not precise, because whenever you say plus, you're really saying that maybe in my parent class, this search routine was deferred. That's why I'm just making that effective for the very first time. But in this case, search is actually already one version. I'm just redefining that to another version. So this is also not correct, right? So you should really say search and then ++. So that'll be the way to understand between plus and plus plus. Think about the plus is really like you inherit something from your parent class that's deferred. You're just making that effective for the first time. Effective the first time. And then when you say plus plus over here, so that means it's already effective from the parent class. That's why it's called redefinition. You can redefine a particular search for as many times as you like in the inheritance hierarchy. Okay. All right. So let me see. I got a question from Robbie. Okay, that's maybe what you meant. Let me take a look. Do we need a loop? Couldn't we just specify a? Oh, I see. So Robbie, Robbie's question was like this. Let's say we got this particular guy here. You can see this part over here is trying to use a loop to compare array member by member. Robbie was asking this. Can we actually say A tilde old A dot detwin? This is actually something I meant to write in the before I wrote the loop version. But on the second thought, this may not work because it depends on what A's the object comparison for A is. So now let me just highlight it and I'll explain to you. Okay. So now in this case, so this depends on A dot objects comparison. For example, let's say if A dot objects comparison is simply false, right? If it is simply false, so that means when you're using this particular tilde, so it's actually going to compare every element just by their references. And now in this case, deep twin is just going to create new references recursively for all the member. In that case, it will be trivially false in this case. So that's why, unless you're pretty sure that A.object comparison is actually true, otherwise, using tilde can easily just give you false trivially if the object comparison is simply just false for A. So Robbie, does it make sense to you? Okay, maybe I'll wait. Okay, so guys, this makes sense to you guys just about this particular part. So my point is, using this is always going to work because you're just going to compare reference by member using the tilde. On the other hand, if you simply say using the tilde on the array level, excuse me, if you only use tilde at the array level, there's one scenario where you may not get what you really expect, which is when the A.object comparison is simply just false. In that case, using tilde is going to compare every member in the array using a reference, as we did in Lab 0 tutorial video. In that case, you'll get trivially false right away. So that may not be what you expect to do, expect to see. All right. Okay, Robbie, thank you. That's good. That's a good question. All right, so guys, so that's about this particular guy about defer and also redefine. Okay. Any questions so far? Okay. So I hope everybody got a chance to actually for your lab number 2, even though it's not in one of the required to do, but I would say the section in your PDF instruction about what's the design architecture for lab number 2, about how you can call defer routines in the database class, and then dynamically you will be calling either the version in the tree DB or linear DB. So that's a very important thing for you to understand in order to maybe get you warm up for your lab number 3 and also later the project, because you're going to use lots of OO properties. Okay, next one. This one is just about clarification for notation. Okay, so clarify about the set membership. Okay, so I think in your lab number 0, when I explain, whenever you say I is of type integer, right? The way I explain it is you can think about the column over here is like a set membership. So when you say I is a member of integer, an integer is simply the set of 32 bits integers. You're saying I is just a member of that, right? That's how we explain it in lab 0. So in this case, this is what we see from the template, maybe from the library template for the design diagram. Your fellow student was asking, can they simply write to say for every S, and then S is a member of S, and T1 is a member of T, rather than using colon? My response would be yes, it would be okay. It is acceptable, right? I wouldn't be so picky on your syntax over here, okay? So this will be acceptable. So you can either use the colon, or you can either use the membership symbol to denote set membership. Either way is actually fine. There's another question over here just about, again, in the template, I actually use semicolon to separate declaration, right? Pretty much like how you declare parameters in Eiffel. So rather than using semicolon, can you just use a comma? Okay, I would say that's also fine. That's also fine, because we're only displaying the diagram to make somebody comprehend better. So if you believe comma is actually can let people read better, that's okay. It will be okay to do this. Okay. Okay, that's an easy question to address. Okay, and then this question here just about the difference between relation and also function. Okay. Relation refers to the relationship between sets. That's correct. Okay. Function refers to a special case of set. Maybe not. That's not what you meant. A special case of relation. I think that's what you meant. Right. So I think other than that, it's pretty accurate. So you can think about if f is a proper function. Okay, that's a membership, meaning that f is just one of the valid function, meaning that every domain value should be mapped to at most one range value, right? That's a function, right? You can look at the more formal definition in the slides. F being a function implies f is also a relation. Okay. On the other hand, if I say f is a relation, that implies f is also a function. Guys, a very quick quiz question for you. 1 and 2, which one is valid? Well, both are valid. Anybody? Yeah, speak up, please.
Only second is valid.
Which one? So which one? Tell me the one that's not valid. How about that?
If there is, if f is a function, then it is surely a relation. But
you're saying one is okay.
If a relation, then it is. Yeah, I mean, yeah, one is okay.
How about 2? Why 2 is not okay?
Yes, because in a relation, so there can be, for example, there is a relation ABCD and to capital ABCD, for example. Then capital A can also match to small a and small b.
Okay, I know what you mean. Good.
And vice versa. I mean, the capital B can match to small a as well. So small a would have 2 images and capital A would also have 2 images. Yeah,
very good.
But
very
that
good.
is not valid for a function. It's only valid for a relation.
Yeah, very good. Thank you. So let me just do roughly what you said. So let's say we got capital A over here and also capital B. So if you think about, let's say, I'll just put number rather than just alphabets again. Let's say if I got 1 and 2, 1, 2, and 3. So if you think about, let's say this particular relation here, A is mapped to 1, and A is mapped to 2, and B is mapped to 3. Okay, so this one here will be a valid relation. However, this is not a valid function, especially you can see in the case of A, you can see A is mapped to more than 1 range value, so that's not a valid function. Okay, it's quite obvious, right? Just something you want to keep in mind. That's the most fundamental difference between the relation and function. Not a valid function. So this is not good. Okay, just put a cross. And Colette mentioned that is it because they can be not one-to-one. I think not really to do with one-to-one. I would say when you talk about one-to-one, out of all the valid function over there, there is you can think about this, right? Think about all the set of all relations is like this set over here, and then only proper subset is actually function, right? And then there might be some proper subset inside the function there. It could be the bijection, for example, 1-to-1. And also injective function and etc. Right? So that's how you can understand the stuff. Okay. All right. So now, so that's about the this one. Okay. Is a valid function if range has more than one domain? What do you mean the range has more than one domain?
I guess, Professor, he meant to say that A mapped to 1 and B also mapped to 1.
Oh, I see. I see. Thank you. So if you have this, for example, let's say, I think that it might be also explained in the slide, but I'll just use a maybe slightly simpler example here. So let's say you got A here, and then you got B here, right? Let's say this. Just make it very simple. Okay, first of all, this must be a relation, right? Relation, no problem. As long as it's it has something mapped to something else, that will be a relation. So relation is no problem. So now, is this a function though? It should be a function because does A map to more than one value? No, A only map to 1, so that's fine. Does B map to more than one value? No, so that's fine. So function also true. However, what this is not is injective function. Injection. I think injection simply means that you can think about every domain value should really map to a unique value. So now in this case, A and B both map to the same range value, so that's not an injection. Okay, so injection is no. And for injection, you can definitely check the definition in your slides. Okay, it's a many-to-one function. Yes, in some way, yes, that's correct. Yeah. Okay, so that's about quick review of the function there. Okay, and remember in your slides, I think there are many other concepts over there. Presumably, you may hopefully you're comfortable with the concept like a power set, subsets, and also bijection, injection, cross products, etc. So if you got any concern about those concepts, you can ask me today or ask me during the office hour. Okay, so that's good. Okay, let me go on. This question here just, okay, your fellow student just asked me to explain why for this particular set difference over here, why would that be not a function? That's basically the question here. Okay, let's try together. Okay. So now I can see S times T as like a cross product, basically. So now this would be basically 1A, 1B, right? Let me just write it out. 1A and 1B, and also 2A and 2B, and also 3A, and also 3B. All right, and then that would be the cross product. Okay, that's a set. 1, 2, 3, 4, 5, 6 elements. And then, so this is the set difference, right? Everything that's in here, but not in here. Okay, but now let's figure out exactly what this is, right? Apparently, this is set comprehension. So let me say we're going to minus this particular set. We're going to get all the xy such that xy is a member of here, but x is going to be 1. In some way, this is more like a domain restriction, right? In some way. So now we want to say you only keep those pairs where x is equal to 1. So that means you got 1a, and also you got 1b. So now when you do the set difference, what you're going to get? Okay, let me just modify that directly. Everything that's in here, but not in here. So that means these two can be crossed out from here. So this will be the final answer. Okay, so now the question is this a function? That corresponds to what we just said over here. Obviously, this will not be a function, right? Because you can see the domain value over here to map to both A and B. So that's one counter example why it's not a function. All right? Hopefully that makes sense. Guys, should I test you something else, if you don't mind? How about this? Let's talk about this set over here. Okay, the pink one over here, right? So now, can I just call this particular set S? Okay. And then, what is the cardinality? Okay, I'll just use the hash sign to say cardinality. What's the cardinality of the power set of S? Anybody? I see some answer over here. Okay, that's good. Okay, I think someone actually said 9. So 9 is actually not the case, right? So here, very good, guys. Thank you. So that's good. The answer should be 8. For those of you who might be having trouble figuring out the power set, thinking this way, right? Let me just write it down here. Let's say if I got X, Y, and Z over here. So the way for you to think about is how many different combinations I can have to really construct the power set, right? You can think about, in the power set, for each set, you can think about every set member in the power set. I can have 2 options for every member over here. I can choose to say include or not include. Include or exclude. And also this can be include or exclude. And this one here is include or exclude. So now more formally, you can think about, you can formulate these as like a binary number. You can think about 0, 0, 0, 0, 0, 1, 0, 1, 0, and 0, 1. Let me just be complete here. And then 1, 0, 0, 1, 1, 0, and 1, 1, 1. 1, 2, 3, 4, 5, 6, 7, 8, right? So now for this particular one, what does it correspond to? That means we exclude X, Y, and Z. So that will be just empty set. Now, if you got 0, 0, 1, so that means you only include the Z over here. So that would be just this particular set, right? One more. What does this mean, for example? That means only include X and Z. And the middle element there is simply don't include it. So that will be X and Z. So now once you enumerate all these sets together, you will actually see in overall, you actually got a cardinality being 8. So you may actually want to think about what's going to be the binary number encoding. So that may be one way to think about how many member sets you can have in the power set. Okay, it's a quick review, which maybe you learned in 1090. All right. Yeah, exactly. You definitely need to include the empty set for sure. It's always a good special case. Okay. So this might be related to your lab 2, I believe. I'm still struggling a little bit about understanding the question, but if you're here, feel free to interrupt me to help me understand what you really meant. So I think it's more about how you can construct a relation, okay? How to use loops to create tuples in the constructor. I presume the constructor over here maybe, okay, I think your fellow student was really talking about this particular one here. So just give me a moment. Let me go to the lectures page. So also this will be relevant to your lab number 2. Okay, let me give you a little bit of hints if that's possible. If you simply go to, for example, 4B over here, right? And then if you go to around the end of the math review, remember there is a small test over here. Over here. Okay, so this is small test, right? You can see here, when you want to create a relation, there are 2 ways to do it, basically. Either you can simply just use make from tuple array, and then you simply make the tuples over here. In this case, I just want to make it explicit for you. So I simply just get all the tuples into the array. You know, I'm just using array notation, so double angle brackets over here, right? So now there's another thing you may want to think about for your lab 2. Okay, let me just mention quickly. I believe your fellow student was trying to ask me how they can construct a relation. Okay, so I would say there are different ways you can do it, right? Either approach number 1, pretty much like what you saw in the slides. You can say creates. Let's say we are now in the model function, right? It's a model query. You can say create result. So result is of type relation. Dot make from array, in this case, you can actually simply enumerate all the array elements over here. But this may not be exactly what you can do for your lab number 2 because you don't necessarily know what to enumerate over here. But that's a good start. Number 2, okay? Approach number 2, you can do as follows. You can say, you can have some local variable array. You can say creates, I'll just say A dot make empty. And then you know how to insert elements into the array, right? So what you have to do is, I'll just write it roughly speaking, right? You may have to go over the database and put tuples into the array. So you might need some kind of loop over here. So I'm going to omit the detail for the loop. Okay, just conceptually, that's what you should do. And then after this, you can say creates result dot make from array, and then put the A over here. Right, that's approach number 2. Okay, and another approach, number 3, which might be most of you have been trying. Number 3, what you can do is you can say, again, you should still say, oh, in all the cases, of course, you're going to, in both case 2 and 3, you're going to say create result, which is a relation. I can say create result dot make empty. And then you're going to run the loop, okay? And then you're going to say result dot extend. And then over here, you're going to get maybe a tuple over here. How can you construct a tuple? The easiest way for you to construct a tuple would be you simply use the square brackets notation. Depending on how many elements you have in the tuple, you're going to just use a comma. For example, if you only got key and value, you're going to put some key over here, and also you're going to put some value over here. Okay, so that's what you can do. You can do either of the 3 ways, but I think 2 or 3 would be the way to go. Okay, either 2 or 3. So I believe that's what the question is about. If you're the person who asked the question, if I haven't really answered you properly, let me know. Okay. Okay, so that's about this question here. Let me go on. I think there's another clarification that's needed over here. Okay. Commands should be used when implementing a model, the abstraction function, and queries should be used when using contracts. But why? It is the case, right? I think I can tell you that it's actually for simple compilation concern, really. Because, for example, let's say this. If you go to the relation class, let me just show you right away. Okay, let me just give you one example over here. So this is the starter code of your Lab 2 project. Okay, that's the starter code. Okay, and then if I simply go to the relation class, let me show you one example here. So you can see there is one. Let me see this. There is one command over there called override by. Okay, first of all, so this is one. Okay, I'll write it down on my iPad, so just bear with me. So we got override by. And then it takes some arguments. Okay, let me show you another one. How do you tell it's a command? You can see there's no return type, so that's why it's a command. Okay, easy to tell. There is another one over here, which is a query version. I think it's called overridden by. I maybe just spelled it wrong. So overridden by here. Okay, so this is just another one. So this one here, you can easily tell is a query because it does have a return type over here, right? It's a query version. Okay, let me write it down, and then I'm going to show it to you. Overridden by, and then it has some return type. Okay, let me return to my iPad. Okay, this one here is simply saying like current, and remember these two routines are actually from the relation class. Okay, so now this is a command, and this is a query. let's say now in your database class, if you ever want to use, you're not sure which one to use. You don't know really whether you should use a command or use a query, right? So now thinking this way, let's say in the context of some postcondition in the ensure, okay? If you simply say model dot override by, I don't know, whatever key it is and whatever value it is, whatever it is, right? Is this going to compile? The blue one, according to what I just put as a signature for you. Hopefully you will see that it's not going to compile. Good, very good. Why? Okay, first of all, it's not going to compile, not compiling. Because override by correspond to the override by over here, which is command. And there is no return type, which means when you are using this alone, it's not going to return a Boolean expression. And Boolean expression is expected for ensure, right? So that's why it's not going to compile. Instead, you actually have to use, the correct one would be maybe model dot overridden by, whatever over here. So this at least will compile. Whether that's correct is up to you, okay? All right, guys, it's a very quick clarification to your fellow students over here, right? So that's what I meant by you definitely cannot use the commands in the contracts, not just from the math model, but for example, you cannot say array dot force in the context of the postcondition. That's also not going to compile, right? You always need a Boolean expression for the contracts. So this is not going to compile if you do it, okay? All right, so let me move on to the next. This one here is actually very good catch by your fellow students here, okay? So they actually caught an error. I'm not too sure, maybe when I did an illustration on the lecture video, maybe I did the right thing, but on the slides, I made some mistake. Let me mention that to you quickly, okay? If you look at the slides, okay, something about domain subtracted and also range subtracted, okay? Domain subtracted and also range subtracted over here, okay? So now if you look at that quickly, this is the R, right? This is the relation. So now when you get domain subtracted over here, for example, we are trying to subtract the domain for A and B. So that means we're going to get rid of A, B, and okay, that's it, right? So now we got C6, D1, E2, F3, but I missed C3. So C3 should be there as well, okay? So that's a mistake from my slides, okay? I fixed that already. So if you re-download the slides, it's there, okay? One more, okay? If I try to do another one, that's about range subtracted. For range subtracted over here, so that one, let's say we want to subtract the range for 1 and 2. So that means every pair with the range value being 1 or 2 should be gone. So 1 go away, 1, 2, and also 1, 2. So what should we get? We should get C3 and also A4, B5, C6, and then F3. See, apparently what we don't get over here is F3. So that's missing, okay? You can see F3 should be there, but it's not in the slides, okay? So just a quick typo fix. So if you re-download the slides, it's already fixed, all right? All right, so that's about, guys, do you have any question about the various operation over here? About when you do restriction, it can either be for domain or it could be for range. And when you do subtraction, it can be either for domain or for range as well. Are you guys okay with that? Any questions about these 4 operations? They are very fundamental. Everybody's okay with the relational operations? Good, okay. So now, another question over here. This one is actually new. So somehow, it might be a common question for you guys actually. So sometimes when you open up some project that's given to you, you might find that, for example, in this case, I will demonstrate to you. In the math model library, for example, you can see these classes, for example, relation and sequence, are simply gray out as opposed to being blue. Okay. So for any class that's actually grayed out, it means the following. So that means none of the existing classes, none of the, how about this? Let me put it in a slightly different way. Not reachable from the root class. Recall what we said in lab number 0 in the very beginning. We said that you can easily set the root class yourself, right? Just go to project setting and set a root, maybe the make routine for the root class to be the entry point of execution. You can think about any class that's actually, for example, think about if the root class is like a node over here, starting node over here. If this is your root class over here, any class who is the supplier of the root class is going to be reachable at the first level. And then any class that's reachable, for example, by this particular class over here, is also indirectly reachable by the root. So you can see it's actually a graph over here. You can think about you're just doing a graph first search and then to see what are the reachable, like a spanning tree for your particular graph, right? So now you can think about any class that's grayed out is not part of the spanning tree. It's simply not reachable from the root class. That's how you can understand it theoretically, right? So now let's say if you really want to check to see what's available there for relation, how can you do it? Okay, let me show you that. In your case, if you simply try the starter code for your lab number 2, okay, let me just show you. You can see under your starter project, relation for sure is actually blue, because remember in the database model query, the return type is simply relation. That's why it's reachable. Okay. On the other hand, we didn't use the back, we didn't use the function, we didn't use sequence in the lab 2. Okay. So now, how can we make it blue? Okay. The easiest way to do it is make it reachable from the root class. So now let me simply, you can see when it's actually grayed out, you can see this the features panel over here is simply just empty. It doesn't show anything. Okay. So now the easiest way to do it, let's say I want to really look at what's happening here for the back class. I can simply go to the root over here, okay, just make it reachable. So what I typically do just for temporary lookup, I can simply declare a local variable over here, and then I'll say b of type back. I believe it takes only one generic parameter, let's say string. So you can see at the moment, back is still grayed out, right? You can see at the moment. So now let me go back to the root class, and then I'm going to compile. So once I do that, you can see now the back over here is now actually blue. And now you can see all the routines and all the features in the back class, and now it's part of the system graph. So now you can start exploring it more easily. Okay, I think there is a practical question about using Eiffel Studio. Okay, just want to show it to you. Okay. Any question about how to use this particular part? Okay. For example, for your lab number 2, if you want to explore the set class from the math models, because at the moment you can see the set. Let me show you once more. If you at the moment the set class is actually not. Let me see. Yeah. Oh, sorry. The set class is already there. Let's say if you want to look at the sequence, in that case, how would you do it? In that case, you just have to make the class reachable from the root class. Okay. Okay, so assuming that everybody's okay with this, so let me move on. So this is another good question here. So I believe your fellow students is referring to the source code provided by week number 4. Okay, let me just refer you to that and just mention that quickly. So where's my lectures? Oh, over here, sorry. Okay. If you go to the lectures page, if you download the source code, especially this one here, specifying a birthday book using the MathModels library, and this one here actually uses a hash table to actually implement the birthday book. So your fellow student was complaining that the follows, right? It seems like the birthday class over there, unlike the one you did for your lab number 0, right? The birthday class you did for lab 0 is actually much better specified for the birthday class at least. So your fellow student was able to create, for example, November 31st. Apparently that's illegal. They were able to create a birthday objects November 31st without having any invariant violation. So apparently that's something that I didn't include in the source code for week number 4. But the main purpose is really to show you the hash table usage and also for math model. So that's why I didn't use it. But it's good that you catch that. So if you wish, you can definitely add class invariant for that particular class. It's definitely necessary. Okay. That's something you can do by yourself. All right. Okay. There's a quick clarification as well. You should always think about when you create a new class on your own, especially starting from lab 3. Whenever you're creating your own class, always think about what should be the invariant property to really constrain the integrity of my objects for that particular class. Always. Okay, another concern over here, if you actually notice that for week number 4 at the end of 4C, I believe, again, let me just show you exactly what I meant. Okay. If you go to 4C, oh, sorry, that's not 4C. Okay, I think it's 4B. Okay, over here. Over here, yes. Okay, so the exercise would be, how would you actually implement the design of a birthday book using maybe, for example, linear data birthday book using maybe array or even a tree? Okay, so that your fellow student was asking for if there's any solution to this exercise over here. My response will be, I don't have solution myself. I'm just suggesting some optional exercise for you. If you actually want to try it and they want me to check for you the answer, I'll be happy to do it. Okay, but I don't have solution myself. But that's only the optional exercise for you to try if you're interested. Okay, but I do encourage you to try the following. For example, in lab number 1, you implemented a functioning splay tree. Why don't you try to use a splay tree as the implementation for your birthday book? That's something you can try. Meaning that you're going to sort the names of the person as the keys, and then the values will be the birthday. And the splay tree itself is like a database for birthday book entries. So that'll be some very easy exercise for you to do. You can just create a new project using Eiffel new, and then put all your tree classes over there, and just create one more class, maybe call that birthday book. And then for the birthday book, you can simply say imp implementation of type splay tree. And then you can try to implement other like a remind and also insert and delete those routines quite easily. Okay, so that'll be some optional exercise you can complete if you wish. Okay, all right. Okay, so now supply type. So again, there's a new question there from yesterday. Okay, so this is actually another interesting question over here. Okay, nothing about how to fill out the generics themselves. Okay, just about how you draw the client supply arrow. Okay. Okay, the question goes like this. Okay, I'll just tell you directly. You can see that over here for the database class. Let me just highlight it here. You can see for the database class over here. Okay, for the new cursor, we actually put iteration cursor. Right. So this is a return type suggesting that there should be a client-supplier relation between database and also iteration cursor. However, the arrow I show for client supplier, so your fellow student was thinking about maybe there should be a client supplier relation over here, and then like that, and then you put new cursor over here, right? Plus, because new cursor is implemented at this level here. But why am I showing this over here, new cursor? I would say this particular rendering of the diagram shows more about a program from the interface, but not from the implementation. Okay, let me tell you why. Okay, this is not wrong. Okay, not okay. I would say cross over here, not wrong, but does not emphasize. Good design. And when I say good design, program from the interface, but not from the implementation. Okay. Okay. I'm just so you know what the how to spell out the principle. Okay. So now what I'm doing here is I'm basically considering there is another declaration over here. You can see there's a local variable here. Remember what I said in the lecture? I said typically you don't really have to show local variable for the client supply. However, if you do believe it's necessary, then you can do it. Okay, so now you can think about this one here. is pointing to item iteration cursor. That's why I'm trying to emphasize this particular one here, right? You can see at the top level over here, the iterable over here is pointing to iteration cursor. So new cursor. So this is deferred. So now at the concrete level, we got database, and then we point to the concrete iteration cursor with new cursor. So that's what I want to emphasize, that the dynamic type. There's another concern over here. You can see the DB cursor over here, it should be the name of the supplier. So I would say it's not really wrong if you say DB cursor over here is actually of type item iteration cursor. It's not completely wrong. However, it's not really emphasizing the iterator pattern. Emphasizing the iterator pattern. So that's the issue here. So now, what I'm doing here is I'm saying that new cursor over here is really the dynamic type for so the item iteration cursor here. Think about this one here is really the dynamic type. Dynamic type of this particular iteration cursor. So that's why I'm just still saying new cursor over here. Okay, guys, is it clear to you what I'm trying to explain over here? Okay, I think again, so whenever you're drawing design diagram, it's really for communication. So let me recap very quickly. The reason that I'm showing a client supply between database and also iteration cursor, what I'm trying to say here is dynamically the new cursor, which I declare over here, dynamically will return an item iteration cursor, which is of this particular type. That's what I want to emphasize. I want to show both the program from the interface, not from the implementation, design principle number one, and number two, I also want to emphasize the iterator pattern. So there are two concerns I have over here. That's why I show it this way. Okay, let me read some question over here from Jiahao. During the implementation, we use some other classes array, but not in header or contracts. Do we have to show client supplier over here? Again, yes, if you use any array or linked list or any library classes, whether to show it or not, is up to your judgment, because remember a diagram is simply an abstraction of your design. So you don't have to show every single detail. You don't have to show every single client-supplier relation in your diagram. You have to be selective. But I think for lab number 2, since it's your first time drawing design diagram, so we try to be very exhaustive about what you should really include in the diagram. But later on, for your lab number 3 and also for your projects, you have to be very selective about what classes and what features you want to include. Because for the project, you can easily go up to more than 10 classes, in which case you really want to know what to show. Okay. So one question from Nora. So if we have a defer feature that returns type string, and it is implemented in a descendant class, are both classes clients of string or only the child? Okay, good question here. Okay, let me just build it up as Nora suggested. So let me say parent and child. Let's say we got parent class deferred, and also we got again child. Apparently there's an inheritance relation like that. Okay, let's say this. If we have a defer feature or defer routine, let's say R, for example. Let's say R over here returns a string. However, it's unimplemented, so I'll simply just put a star over here. Okay, so that means it's deferred. And let's say in the child class, I make it effective. So R also returns type string. And this will be effective. So now, in this case, should we consider child as a client of string? Yes. A client of string. And also here, is parents clients of string? Also yes. in terms of the client-supplier relation, what should we show? Apparently, we got two client-supplier relations here. One is here. The other one is here. Which one do you want to show? Of course, you may decide to show in this way here. For example, you can say from clients to supplier, right? Let's say this. So I can show also over here if you wish. You know what? Actually, you know what? Let's say, let me draw a little bit better. Because we're pointing to the same class, so a single one will be okay. Let's say this is a string class, which is library class. Typically, we don't show that in the detailed view. String is effective, right? And then you may have one thing over here to say, this is the R, which is deferred. And you may also get over here another client supply over here, which is R, effective. Okay, that'll be one way to show, but depending on what you really want to show for your particular application, you might find that it will be enough just to show this particular client supplier. Or you might decide it will be enough to just to show this particular client supplier. Or you decide that you should show both. Again, which one do you want to show? Up to you. Okay, but the bottom line is both the parents and the child, they are clients of the string class. That's the bottom line. Okay. So Nora, does it make sense?
Yes, thank you.
Very good, very good. Okay, next one. Showing model in the design diagram. I think this has to do with the lecture 4B, when we talk about the birthday book, creating abstraction for the birthday book. Okay, let's take a look. Let me just see how far I am towards the end. I think we're getting to the very end. Okay, we got three or four more, okay? Okay, for this particular guy here, okay, this is interesting, okay? Your fellow student question was, here, when I draw the arrow over here, I say model over here, and then I say it should be a function, and then name, and then dot dot. So dot dot simply means the birthday here. So that means I'm emphasizing client-supplier relation on the birthday type. That's what I'm emphasizing here, right? And your fellow student question was, what if we want to emphasize the function? Okay, good. So now in that case, how would I draw it? Something like this. In that case, we will still get a model over there. Okay, just model. Okay. Okay, so you got a model over here. Simply just got model. And then the model over here, let's say it's implemented. For example, I'll just put a plus over here, depends, right? And then depends on whether you want to show the function class in the detailed view or compact view. Let's say we show in the compact view, just make it easier. So now what I can do is I can put the class over here, so that's a function class from the math model. And then I can say plus over here, right? However, now in this case, you want to instantiate also the generic parameter over here. So now it will be function of name and also birthday. So to be more complete, you should say name and also birthday. Okay, that's what you should do, right? I'm just going out of the circle, but when you do it on the draw.io, you can make it prettier. Okay. So now the point is, if I want to emphasize this particular client supplier by emphasizing it's really a function type of name and also birthday, that's what I can draw. In this case, I don't have to do like what I did before. You can see really compare option number 1, which we did in the lecture, and also option number 2, which we're doing now. So these two just putting different emphasis, but eventually they're really denoting the same client-supplier relation in your source code. Which one should you show? Again, it's up to you, but you shouldn't show both. That'll be redundant. Okay. Okay, so that's about this particular question here. Okay, hopefully everybody is okay. Okay, so now this is another question about the birthday book example. So your fellow students, they understand the mathematical representation of the postcondition for the same contents, right? So this is the mathematical predicate logic over here, right? They don't understand how to write it in Eiffel. They want to see how they can translate it, right? Why don't we do it together, right? That might be helpful to your lab 2. I don't know. Let's try. So you can think about, So here, when we say for every name and date pair, or I would say typically when we say this means tuple. And when we use parentheses, we meant pair. This is like a mathematical description, right? Mathematically, if you want to write a pair, maybe as a member of the cross product, you would say parentheses. So that's a pair. So in Eiffel, if you want to create tuple, you use a square brackets. So that's the syntactic convention we're adopting here. So you're saying that a result is simply just a function. So now we're basically saying for every tuple that's in the result, we want to say that particular tuple is really in the implementation. Okay, that's basically what we are saying here. Okay, but you know what? You can check for me. I believe if you want to do so, we want to say everything in this particular result function. So in that case, if you want to quantify over a collection, you're basically talking about across. You want to go across that particular result. So how do we do that? We can say across the result is, let's say, X over here. And let me draw your attention very quickly to yesterday, right? Yesterday, let me just go to that particular part in the beginning. Remember from yesterday, I started with our session with this particular example. Just about if you say you want to go across this particular model, which is of type relation, what should be its type? It turns out it's a pair, right? So now the function will be something similar. It will also be a pair. So that would mean over here. So let's say, let me come back here, okay? So I think to be more precise, this should be maybe a parenthesis to be a pair. So that should be the correct notation, okay? But in the diagram, we may not be so picky. So as long as you're being consistent, but if you really want to be 100% correct, I think this will be the tuple and this will be the pair. But sometimes if you're really supposed to write this in the diagram, but you wrote this, that would be okay. But of course, in Eiffel Studio, everything must be compilable. So that would not be okay in that case. But in the diagram, I would say either way is fine, okay? So now let's try this over here. So now we are saying every X. So you can now think about this. You can think about this guy over here is really X. It's a pair. Now, if you say X dot key and also X dot value, they will not compile because for pair, they don't have any query called key or value. They don't. Okay. So what do they have? You can look it up in the Eiffel Studio, but they got first and second. Okay. So they got you can say X dot first and also X dot second. So that's what you need to do. Okay. And then let's see this. So result is X, and then we want to do universal quantification over here. Now we want to say this particular name and date pair, X is in the implementation. So let's say the implementation we have, I think for your lecture series example, we're talking about hash table, let's say. So now you want to say, first of all, X dot first, which is the key, should be a valid key in the hash table. And also the corresponding, let me just write it more properly. We're going to say X dot first, which will be the key. That should be a valid key in the hash table, number one. And number two, the corresponding value for key should be equal to the second. Okay, let me write it out quickly. Okay, you want to say something like implementation dot, I think it's something called has key or something, but you can check in the hash table. Has key, and then I can say over here X dot first. Okay, and also if you try to inquire about the corresponding value for the key, you can say implementation dot item, I believe. Okay, and then you can say X dot first. So that one is going to return whatever that's in the hash table. This one should be matching X dot second. So this part over here, let's see this, has key and also, so has key over here, and also you're trying to say item, and then you want to say that's equal to x dot second, right? So you just got to do these programming constructs to really say that's corresponding to the mathematical description over here. Okay. Any question about this short translation here? Any questions?
I have a question.
Go ahead.
Can we just say result is a subset of implementation? Just result and the subset thing implementation instead of having.
You mean say result?
Yes, even though we used across in Eiffel, can we just say result is a subset of implementation?
Result is a subset of the, you mean just in the diagram, right?
Yes, in the diagram.
In the diagram. So let me just write down exactly what you're suggesting, and then we'll discuss. You're saying result is simply a subset of the implementation.
Yes.
Okay. I don't think this is actually correct, because if you think about it, result, we know that result is simply a function, right? However, implementation over here is actually a hash table, right? So what we're really trying to do over here is to say every, if you think about result being a set of pairs for the function, and now think about implementation being a set of entries over here, and we're saying that they are equal to each other, like a same set. However, if you only use subset, this may not be good. But if you also use just equal sign, that's also not to be very compatible. So I think that you will have to do some, like a universal quantification here to say.
Okay.
Okay, good. Okay, I got one question from Jahao. So create pair, can we use pair in contrast to simplify it? Okay, so what you're saying is, remember in lab number 0, we learned about anonymous object, right? You can create objects on the fly without declaring that, right? So I think what Jahao is saying is like this, right? Let me just write it down. If you got, for example, creates right, time really flies. I think we only got 10 minutes, but I'll try to control the time, because I do promise your fellow student I need to discuss that quiz question quickly, okay? But I'll do that, okay? Pair, of course, one common mistake which I saw from you guys' email questions. If you only say create pair and then make from, okay, let me just make more space for myself. Make from tuple. For example, if you just say a tuple, maybe 2 and also 3, right? By the way, this will not compile, because if you're trying to use a generic class pair, you have to give, you have to instantiate that. So you got to say over here, pair should really be instantiated. Maybe either you would say integer, or you might just say k and v. Okay, so in your lab 2, I think most likely it's going to be k and v. Okay, just don't forget to include the instantiation. And Jahao's question was, this seems to be a very long expression here. Can we simply use just to say pair t? I'm afraid you cannot. It would be nice, wouldn't it? So no, you cannot do it. You have to create anonymous objects. Okay. 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 So Pavel, you actually got some question over here. Okay. Okay. So what you want to be careful. Okay. I think you got some misunderstanding there. We're saying this. You know what? Let me write this part separately. I know it's a little bit hard to read. So this part over here, I think that's what you are confused about. Let me write it down here. Okay. So this part should really be something like this. Imp dot item x dot first. Tell them x dot second. I think that's how you should read it. So we are saying that we are not comparing x dot first and x dot second together. No, that's not what we're doing. We're saying that the associated value for x dot first, which is a key in the hash table, should be equal to x dot second. That's what we're doing. Okay, if that makes sense to you. All right.
Yeah, thank you.
No problem. All right. Good. Okay, guys, let me move on. Okay, this one is also quick. Okay, that's a common mistake. Okay, your colleague was asking about, is the following correct? Okay, you can see my iteration cursor for string and also G. So notice one thing here for lab number 2, we actually gave you all the decoration for the iteration cursor. So I would say for those of you who may want to explore the lab a little bit further, do study the decoration header that we gave to you for every class, right? Because later on, if you want to apply generic classes in your own application, you might need those knowledge, okay? So the question was, if I declare my iteration cursor over here, can I say, rather than using just G, okay, let's say this, not this. Can I say this? Before I tell you my answer, anybody want to help your fellow students? Is this allowed or that's not allowed? Anybody? I said I can see no. Jalil, you want to explain to your fellow student why not? Or because it's already a class. Very good. Exactly. So think about, so don't forget, this is when we declare a class. So now the string cannot be a valid name. To declare a new generic parameter. So that's why we said every time when you declare you declare the generic parameter, every name over here should not be an existing class, right? So this will not be good. Okay, so that's a quick response. Good. Okay, so now I think that's the last one. Okay, let me just mention about this quickly. Okay, I think this quiz number, the question here, this is just one of the versions. The version you took may not be exactly this one, but I'll just mention the part that your colleague might be a little bit confused about, because there was an incorrect answer, which I fixed already, okay? And then we grade everybody, so don't worry about it. I think your colleagues might be confused about, let's say this, but let me just choose the one that they're confused about. Let's say here. Okay, how about this one here, okay? So we got 2 classes. We got class C, and also we got class D, right? We got 2 classes. And then we actually got objects of type D. So what I will do is, so objects of type D at the runtime is really pointing to an object of type D. And D actually got 2 attributes over here. So we got J of type, excuse me, of type integer, for example, 23. And then we also got C of type C, right? So that might be pointing to another object over here. So now this will be class of type C. And then that one there also got T. And that one also pointing to maybe some string value, for example, Alan. So that's how you can understand the runtime structure of this question here. So now, what will be the equality here? Apparently, you can see we are trying to do, let me make it bigger for you. We are really trying to compare the objects reference over here. So now you want to know, how do we visualize obj.twin? So that's a question. obj.twin, okay? So now let's try that. If you try to do object.twin, so it's gonna be just, first of all, you're gonna create, let's say obj.twin, okay? That one there's, first of all, you're going to create a new object here of type D, right? For sure. And then you're going to get J, and in this case, it's primitive type, so that'll be 23, right? And now for the C over here, for the first level, we actually don't do any new objects creation anymore. Instead, it's going to point to this particular object over here, aliasing, right? We talk about shallow copy. And then let's compare them. So now let me make it bigger again. So now on the left-hand side, when you say obj.c.t, so obj.c.t is really pointing to this particular string value over here. On the other hand, when you actually got obj.twin.c.t, right? So obj.twin is basically this particular object over here, right? That's the object we're talking about. And then .c.t. .c is really pointing to just the same object over here. And then when you say .t, is really referring to the same string object. So that's why it should be true. Okay, I think that's the main question your colleague was actually wondering about. They also got a question about how you can visualize others. In that case, I would suggest follow the same mechanism over here and try to visualize the object structure yourself. Okay, and then I think that's a quick discussion about the quiz question. Okay, I think it's about 1 minute from 4 p.m. But I'm willing to take some Lab 2 questions if you have any. Any question about Lab 2? If you want to ask me quickly, I can stay for 5 minutes before I run my office hour. Anybody?
Hi, Professor.
Go ahead, please.
I have a quick question. How do we convert from tree node like KV to pair KV?
Okay.
So, for example, in a lab we can get like a list of tree nodes, and we want to get a list of pairs of
yeah.
KV.
Okay, no problem.
Thank
I think let me give you some hints for everybody. That's okay. So so that's your starter code. Okay. So let me now simply just go to, first of all, go to the trees. If you go to tree nodes, in order for you to get a key, you will say dot key, right? And then in order to give you the value, you want to get the value, right? Okay. Okay, let me just want to pair. Okay. And oh, one more thing I want to show you. There's another thing. Okay, we got a key, we got a value. Now you want to compare the tree node into a pair. That's your question. So now let me take a look at the pair class as well. The pair is one of the math model class. So if you go to pair, how can I construct a pair? You can either say make over here, or you can say make from tuple. Either way, I think make might be just easier because just give 2 parameters over here. Okay, let me show you. I'll show you both. Okay. So now how can we do it? Let's say if you got already some TN, the tree nodes of type tree nodes in your context, assuming that. Let's say maybe whatever type it is. Okay, it doesn't matter. Okay. How can you create a pair from TN? 2 ways to do it. You can either say creates, let's say pair. Let me just say it's KV, for example. And now don't forget, you must say KV over here, okay, to use a generic class. You can either say the make, I'm just making an anonymous object for you, so you can also use it in the contracts if you wish. The make, and then you can say tn dot key, and also tn dot value. Okay, that's one way to do it. Okay, another way to do it, you can say creates. I'm just calling another the other constructor. Again, you have to use it. You have to instantiate all the generic parameter. K and V. So now you can say make from tuple. I think Jaha suggested this alternative. Make from tuple. So now, rather than passing 2 values over here, you're going to pass just a single value, right? So now what you can do, I'll just put it here, right? You can construct a tuple right away, okay? I saw some of you, when you show me your code, you try to say create tuple.make or default make. You don't need that. The easiest way to construct a tuple is just by using square brackets. So now you can simply say a tuple over here and tn dot key and also tn dot value. Okay, does that answer your questions? I hope. All right. Okay, any other quick question for Lab 2?
Thank you.
Sorry, I couldn't hear. Your sound was a little bit distorted. Yeah. Any other questions? Or okay, so okay, I'll wait for maybe just a few more seconds in case you want to speak up. Yeah, questions.
Can I ask a question first?
Okay, how about you be the last one? Okay, go ahead.
Like I said, in the contract, if I have the value for K and the value, can I just use brackets K comma value to represent the pair?
No. You know what? There's something I want to double check. It's a good question. Is it Jahao or you're somebody else?
Yeah,
Jiahao, so can you send me an email about this particular question over here? I need to try it out on my computer very quickly. If it turns out you can do it, then I will maybe put on a forum for everybody to share for that particular part. Send me an email.
I mean in a diagram, not in actually.
The code in the oh, you mean in the diagram?
In diagram, yeah, to save some space because the
I would say, as I
really
said before, in order for you to do let's say pair, use parentheses over here, right? And if you want to say tuple, you just use square brackets.
So, but not for the the make from tuple.
You don't need to say make from tuple. I don't think that's fine. I think for the diagram, for example, let's say this. Let's say if this is your actual code, let's say, right? This will be too much to really show in your diagram. So for this one, if you want to show in the diagram, this is what you can show. Eventually, it's going to be a pair, right? So what you can do is you can simply say tn dot key, tn dot value.
But what if I only have the tuple of this two value? I don't have the value inside the tuple. Like I cross the database, so I get a tuple for this.
Yeah, in that case, you can just say T for tuple, right?
But I need to compare with a pair.
In that case, you might say, for example, what? Yeah, you're talking about a little more specific. For example, let's say if you got a tuple T, you can definitely say T dot key and also maybe T dot value, right? For example. So this will be a pair from the tuple, right? And then you want to say this is equal to this. That would be acceptable.
That's okay. Okay. Thank you.
Yeah, I think for the diagram, we wouldn't be so really unless you got very serious mistake, like you simply put something that's uncomparable together. Otherwise, I think if you put notation like this, that'll be okay. You can simply construct a pair or construct a tuple on the fly, so that'll be okay. Just for the diagram. Okay. So Robbie here got a question here. Why can I seem to declare a local variable in? Why can you not, right? Why can you not declare a local variable in the post condition? So in the post condition, as I said previously, let's say under the context of ensure, right? You definitely cannot say, for example, local and then something here and then do. No, you cannot do it, okay? The only way you can introduce local variables for post condition or any contracts, there are only two ways. Approach number one, if you say across something here, and then you can say is. So this is the local variable you can introduce, dummy variable. That's one way, okay? Number two, if you got the attached syntax, if you say attach certain expression over here as, so this will be another local variable you can introduce, and then you can use them. So these are the only two ways. For number two, there is a slight variance for typecast, which I will discuss when we talk about inheritance after the reading week. But for now, you just keep in mind. So you cannot declare local variables directly under contracts. So if you want to really introduce local variables, there are only two ways, either using across or using attached. Okay? All right, so now let's say this. Do all the post conditions have to be written in terms of model? Yes, that's the goal. I would say you should really try as much as possible writing, depending on how the hints are given. Sometimes the hints suggest that maybe you want to go across the database, the current, or sometimes you may want to go across the model, and sometimes you may want to go across the result. So it depends on how you write it. But in principle, it should be written in terms of the model. It should be. Okay, so guys, I think we're running over time, but hopefully that answer all the questions you need, at least for lecture series number 4. I still got office hour right now. I'm gonna go into my office hour Zoom right now. If you got any more questions, you can ask me, or I still got office hour tomorrow afternoon, okay? All right, so good luck to your quiz number 4. If you got any questions, get in touch with me, all right? So talk to you later.
Thank you.